Question 1. Which of these numbers is 1 more than a multiple of 5? Circle your answer for 1 mark. 15 is a multiple of 5, 19 is 1 more than 18, which is not a multiple of 5, and 26 is 1 more than 25, which is a multiple of 5. 26. Question 2. Which of these numbers has exactly 3 factors? Circle your answer for 1 mark. Let's write down the factors of each number. 3 has factors of 1 and 3. 4 has factors of 2, 2, 4, and 1. 5 has factors of 1 and 5. And 6 has factors of 1, 3, 2, 6. 4 has 3 factors, 2, 4, and 1. Question 3. Which of these numbers is 6 less than minus 1.4? The calculation we need here is minus 1.4, take away 6. So minus 1.4, take away 6, which is minus 7.4. We can do that on a calculator if we need to. Question 4. Which shape is congruent to shape X? Circle the correct letter for 1 mark. A congruent shape is a shape that is exactly the same and it can be rotated. So for example, B is not exactly the same. We can see this cross shape here, which doesn't occur in shape X, so B cannot be the correct answer. Looking through the other shapes, we see that D is a rotation of X, and that must be congruent. Question 5. The map shows the positions of 2 ships, A and B. Work out the actual distance between the ships. The first thing we need to do is join the two, A and B, which I've already done, and then measure this distance with a ruler, which gets around 8.6 centimeters. Next we need to use the scale to convert this into kilometers. So 8.6 centimeters. Each centimeter represents 2.5 kilometers, so 8.6 centimeters represents 8.6 multiplied by 2.5. We can put that into the calculator, it gets us 21.5 kilometers, because we've now converted into kilometers. Question 6. A gym has 275 members. 40% are bronze members, 28% are silver members, and the rest are gold members. Work out the number of gold members. So we need to figure out what percentage of them are gold members. So we take the full amount, 100%, subtract the 40% of bronze members and the 20% of silver members, get 32% that are gold members. Now we need to find out the number of gold members, and we'll do that by finding 32% of the total, which was 275. As a decimal, 32% is 0.32, and we'll multiply by 275 to find out the number of gold members, which is 88. Question 7a. Alan is looking at number machine problems. He says, if I know y, I can work out x. I subtract 3 and then I add 5. Does this method work? Normally, if we had y, we'd do the inverse operation here, which would be to add 5, and then the inverse here, which would be to subtract 3. And then we've had x. Alan says he can do those in the other way around, which we can do for addition and subtraction. For example, 10 take away 7 is 3, and minus 7 plus 10, which is the opposite way around, is still 3. The order of these two operations doesn't matter. So this method does work. And the reason being is that we can do these two operations, addition and subtraction, in any order we want. Question 7b. He says, if I know D, I can work out C. I divide by 3 and then subtract 5. Does this method work? The normal method would be to subtract 5, then divide by 3. And in this case, it doesn't work. We can't do division and subtraction in the same way. For example, let's take an example of C is 1, so multiply by 3, and then add 5, we would get 8. And if we're doing that in reverse, we'd normally do 8 take away 5, which is 3, and then 3 divided by 3, which is 1. However, if we use Alan's method, we would have 8 divided by 3, which is 8 over 3, then subtract 5, which is clearly not 1. So this method doesn't work because we can't rearrange the order of these two operations. Question 8a. Solve 5w minus 11 equals 24. Our first step will be to take the minus 11 and add 11 to both sides. On this side, we'll only have 5W left. On this side, 24 plus 11 is 35. The next step, we have 5W and we only want W, and to get rid of that, we'll divide by 5. 5W divided by 5 is simply W, and 35 divided by 5 is 7. That's our answer for 8A. 8B. Write an expression for the total cost in pounds of X jumpers at £15 each and Y shirts at £12 each. So, for the jumpers, we have £15 multiplied by the number of jumpers we have, which in this case is X. So the cost of all the jumpers will be 15X. We also have £12 multiplied by the number of shirts, and we want the total cost, so these need to be added together. That's our expression. 8C, simplify X plus Y times Y, and we need to look at what order we would do these in normally, using BODMAS. Multiplication needs to be done first, so we'll have X plus Y squared, Y times Y, and then add up these two X's, which gives us 2X plus Y squared. Lucy says 3 is odd and 2 is even. So when you add a multiple of 3 to a multiple of 2, the answer is always odd. Is she correct? So what we can do for these kind of questions is try and find a counterexample to see if she's incorrect. For example, 6 is a multiple of 3, and 4 is a multiple of 2. If we add these together, 6 plus 4 is 10. We have a counterexample. This answer isn't odd, so she's incorrect. Question 10. Tom earns £9.20 per hour. He works for 24 hours each week and 48 weeks each year. He pays tax if he earns more than £10,000 per year. Does Tom pay tax? So, we have £9.20 per hour, 24 hours each week, and 48 weeks each year. If we do that multiplication, we get £10,598.40, and that's greater than 10,000, so yes, he does pay tax. Question 11. 3 boxes contain counters. There are 62 counters in total. The total number of counters in box A and box B is 34, and the difference between the number of counters in A and C is 9. Work out the number of counters in each box. We know the total for A and B, so if we take that total away from the full total, so 62 minus the total of the counters in box A and B, we'll get the total in box C, which is 28 in box C. Our next step, we know that we have 28 counters in box C, and the difference between the counters in A and C is 9. So if we take away that difference, we'll get the number of counters in box A. That's 19 in box A. Our final one, we know that the sum of the counters in box A and B is 34, and we know that there's 19 in box A. So if we take that away, we'll get the number in box B, which is 15 in B. So our answer is 19 in A, 15 in B, and 28 in C. Question 12. The pie chart shows information about the sales of 800 tickets. There were twice as many adult ticket sales as senior ticket sales. Show that there were 140 senior ticket sales. First, let's figure out how many degrees this whole section is. That's 360 minus 171. This angle here is 189. We know this is divided into 3 parts, 3 equal parts. There's senior here, and then adult, which takes 2 shares of that. So 189 divided by 3 is 63 degrees for the seniors. And conversely, if we wanted the number of degrees for adults, which will be useful later, that's 160 degrees. Next, we take 63 degrees divided by the total number of degrees in the circle. That's the fraction of the total that seniors account for. And then we'll multiply by the number of tickets sold, 800, which gives us 140 senior ticket sales. Question 12b. Draw a bar chart on the grid to represent the child, adult, and senior ticket sales. We have the senior ticket sales from before, That was 140. We need to calculate the adult and child ones. The number of degrees for the adults was 126, so we divide that by 360, multiply by 800, which gives us 280 adult tickets. Same for the child tickets. We can either find 171 over 360 and then multiply by 800 again, or we can take these two away from the 800 total sales. Either way, we get 380 child tickets. Next, we need to make a bar chart. So on this axis, we'll have the number of tickets. And on this axis, we'll have our three categories. We need to account for at least 400, so we'll go up to 400 on this axis in 50s. And down on this axis, we'll have our three categories. So we have child, adult, and senior. Next, we need to plot in our bars. So the child one is going to be up at 380, which is here. The adult one is going to be up at 280, which is here. And then the seniors go to 140, which is here. Finally, we just need to put in our full bars. Now that we've got the bars filled in, the only last thing we need to do is to make sure that we've got a label for this axis, which is age group. Question 13. Alice makes cards. Each card uses 42 centimeters of ribbon. She has 1000 centimeters of ribbon. Work out the maximum number of cards she can make. We need to divide the 1000 centimeters by the 42 required for each card, and that gives us 23.8. She can't make 0.8 of a card, so she can only make 23 cards. For question B, how much ribbon will be left over? Well, we start with 1000 centimeters, and we need to take away 23 cards multiplied by the 42 centimeters of ribbon that takes, which leaves us with 34 centimeters of ribbon left over. Question 14. Luke saves 10p coins and 20p coins. He has 3 times as many 10p coins as 20p coins, and a total of £17. How many 10p coins does he have? So, we've been given the ratio of 10p coins to 20p coins, and if he's got 3 times as many 10p coins as 20p coins, for every 20 pence, he's going to have 30 pence in 10p coins. The total here is 50 pence. We know that his full total is £17, so to get from 50 pence to £17, we need to multiply by 34. We can find that out if we need to by taking 17 and dividing it by 0.5, which would give 34. So let's multiply both sides of the ratio by 34 as well. On the left hand side, 30 times 34 is 1020, and 20 times 34 is 680. So we have 1020 pence in 10 pence pieces, So we just need to divide that by 10 pence to get the number of 10 pence pieces, which is 102. Question 15. A company has bikes for hire. The cost in pounds to hire a bike for n days is given by the formula. Write down the cost to hire a bike for 1 day. If we're hiring a bike for 1 day, the formula reduces to 12, 27 over 4, 1 minus 1. 1 minus 1 is 0, so this whole thing cancels out, and we simply have C equals 12, so £12. 15b. We have a special offer. We get to hire a bike for £9 per day. Is it cheaper to hire a bike for 7 days using the special offer? So first, let's calculate the offer price. £9 a day is 9 times 7, which is £63. Now let's calculate for 7 days using the formula. C equals 12 plus 27 over 4, 7 minus 1. So the cost here is £52.50, and it is not cheaper to use the offer. Question 15c. The graph shows the cost to hire a bike for 1 to 5 days at a different company. The cost in pounds to hire a bike for n days using this company is given by the formula. Work out the values of A and B. There are a few ways we could do this. We could rearrange this to be y equals mx plus c, then find the intercept and the gradient and do it that way, or we could use some test points. For this one, we're going to use test points. So for example, when n is 1, this is the number of days n here, the cost is 9. So C is 9. So in that case, we have C 9 equals A plus B 1 minus 1. However, like before, this cancels, so A equals 9. Let's use a different test point. So for n equals 2, we know the cost is 17. So the formula is 17 equals 9 from A equals 9 plus B 2 minus 1. So 17 equals 9 plus 1 times B. That means B is 17, take away 9, which is 8. Our two values, we have A equals 9 and B equals 8. Question 16. A company's logo is a pentagon, has exactly one line of symmetry, has sides with whole number lengths, and has a perimeter of 15 centimeters. Draw a sketch of a possible logo, and label each side with its length. So for example, we could have a shape like this. Finally, we need to put in the sides. We know these need to be equal on both sides, so we can have a base length of 5, 4, 1, 1, and 4. Question 17. Mr. Jones works for 5 days each week. He uses his car to travel to work. He drives a total distance of 24.2 miles a day. His car travels 32.3 miles per gallon of petrol. Petrol costs £1.27 per litre. And if he uses the bus to travel to work, he can get a weekly ticket for £19.50. We have a conversion for gallons to litres, and we need to figure out if it's cheaper to use the car or the bus to travel to work. Let's figure out the cost for the car. We've got 5 days, multiplied by 24.2 miles, is 121 miles total that he needs to travel in the week. Next, let's take that 121 miles and divide by the number of miles he gets per gallon. That gives us 3.746 gallons of petrol that are required. Each gallon of petrol is 4.5 litres, so that converts it into litres, and each litre costs £1.27, so that will give us the total cost, which is £21.40. This is greater than the cost for the bus, so we conclude that the bus is cheaper. Question 18. Here are two number machines, A and B. Both machines have the same input. Work out the input that makes the output of A 3 times the output of B. If we're using the same input and we want to find that input, let's use an unknown, so we'll call it X. And let's figure out what the output is for each of these. So the output for A is X times 7, so that's 7X, minus 4. So that's our output. And for B, we have X times 3, which is 3X, then plus 2. We want the output of A to be 3 times the output of B, so we'll set up this equation. 7x minus 4 is 3 times the output of B, 3x plus 2. Now we need to solve to find the value of x. First, let's expand the right-hand side. 3 times 3x is 9x. 3 times positive 2 is positive 6. Now let's sort out the constants on each side of the equation. Since I notice that we have fewer x's on this side than this side, let's move the constants onto this side. So, let's take away 6. We get 7x minus 10 on this side, minus 4 minus 6 is 9x. Now let's take away 7x. On the left-hand side, we're left with minus 10. And 9x take away 7x is 2x. Our last step, we have 2x, we only want 1x. Let's divide by 2. We have x on the right-hand side, and negative 10 divided by 2 is negative 5. Our answer, x equals negative 5. Question 19. Joseph runs 400 meters in 1 minute. He assumes he can run any distance at the same rate. He says, I would run 10,000 meters in 25 minutes. Tick a box to show whether his time to run 10,000 meters is likely to be accurate. Let's first check his calculation. So 10,000 meters divided by 400 meters is 25. So, assuming that he'll take 25 minutes if he runs at the same pace makes sense. However, we assume that the time will be longer because this assumption here, the assumption that he can run any distance at the same rate, is incorrect. Clearly he's going to run 10,000 meters at a much slower rate than if he would run 400 meters. So that's our conclusion. Time will be longer, and no, he can't run a 10,000 meters at the same rate he does 400 meters. Question 20. Which sequence is a geometric progression? Circle your answer. A geometric progression increases by a multiple of a number each time. So for example, if we started with 3 and multiplied by 2 every time, we'd get 6, and then we'd have 12, and then we'd have 24. So we're looking for a sequence where there's a multiple that goes up each time. This sequence is just a normal arithmetic sequence. There's an addition. This sequence is a non-standard sequence, and so is this. And this is our sequence here. We've got a multiple of 2 every single time. Question 21. This pyramid has a square base. We've been given the formula for the volume of the pyramid, and we need to work out the volume of the pyramid. We have the perpendicular height, that's 17.4, but we don't know the area of the base yet. We have one side, and we know it's a square, so the area of the base has to be that side length, 12.9 squared, so 12.9 times 12.9, and that equals 166.41 centimeters squared. Our next thing is to calculate the volume. So we know the volume is 1/3 times the area of the base, we calculated that before, multiplied by the perpendicular height, which we were given here. If we multiply all those together, we get 965.2 centimeters cubed to 1 decimal place. Question 22. We're given a set, and we're given that S is the square numbers and E is even numbers. Complete the Venn diagram. So we need to sort all these numbers into these two sets here. For example, 1 is a square number but not even, 2 is an even number, not square, and we continue from there onwards. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Numbers that aren't contained in these two sets go outside, but still within this area here. Question 22b. One of the numbers is chosen at random. Write down the probability of the intersection between square numbers and even numbers. So we have one number in the intersection between these two sets, and we have 12 numbers in total. Our probability is 1/12. Question 23. A coin is rolled onto a grid of squares. It lands randomly on the grid. To win, the coin must land completely within one of the squares. Mira and John each roll the coin a number of times and record their results. We need to calculate two different estimates for the probability of winning, so we have Mira's estimate, So probability of winning Mira is the number of wins, 6, over the total that she observed. That's 44 plus 6. So her probability is 6 over 50, or if we're simplifying, 3 over 25. Let's calculate the probability for John. So the probability of winning based on John's data is 28 over the total, which is 28 plus 72, 100. And we can simplify that down to 7 over 25. Question 23b. Which of the estimates is a better estimate for the probability of winning, with a reason for our answer? The better estimate in this case is 7 over 25, and the reason is that John used a larger number of trials to calculate that probability, so it's more likely to be closer to the correct probability. So it was calculated using a larger number of trials. Question 24. In a sale, the original price of a bag was reduced by 1/5. The sale price of the bag is £29.40. Work out the original price. Let's call that X. So we know that the sale price is 4/5 of the original value, which was X. Turn that into a calculation. We know 4/5 multiplied by X equals the sale price, which is £29.40. And if we want to figure out X, we need to divide £29.40 by 4/5, and I'm going to call that 0.8. 4/5 is 0.8. So we can just do that calculation, which gives us 36.75. Our answer, £36.75. Question 25. Which of these is not used to prove that triangles are congruent? Circle our answer. The answer here is AAA, and the reason being we have two triangles with the same angles, but they could be different shapes. These are not congruent, they are similar, but not congruent. Question 26. E is the centre of rectangle ABCD. We need to work out the length DE. Since this is the centre, the length DE is half of the length from D to B. So let's work out the length from D to B. We have a right-angled triangle here, and two of the side lengths, so we can use Pythagoras' theorem. A squared plus B squared equals C squared. Label this side A and this B, and we have the hypotenuse here C. We have A squared, 20 squared, plus 12 squared is C squared. That gives us that C squared, 544. The C is the square root of 544. C is the length D to B. We want half of that length, D to E. So we can conclude that the length D to E is a half of the square root of 544. And if we put that into a calculator, we'll get that this is 11.7 one decimal place. Question 27. Circle the equation of a line that is parallel to y equals 5x minus 2. If we have a straight line, that's usually in the form y equals mx plus c, and parallel lines have the same coefficient of x, the same gradient. So we're looking for a line here that has the same gradient, and that's this one here. Y equals 5x plus 2 is parallel to our given line. Question 28. At a school, the number of boys to the number of girls is the ratio 9 to 7. There are 116 more boys than girls. Work out the total number of students at the school. First, let's put the ratio down. Boys to girls is 9 to 7. In this case here, the difference is just 2. We need to multiply the ratio to get to the point where the difference is 116, and that'll give us the actual numbers of students in the school. If we divide 116 by 2, we find out that we must have multiplied by 58. So let's do the same for both of these. Multiply 9 by 58 and 7 by 58. So first, 9 times 58, that's 522. And 7 times 58 is 406. Next, to find the total number of students in the school, we just need to add those two together. That's 522 plus 406 equals 928 students in the school. Question 29. Circle the equation with roots 4 and -8. A root of an equation is a number you can substitute in to make the equation equal to 0. For example, in this one here, one of the roots is x equals 0, because we can substitute x in as 0, and we'll have 4 times 0, which is 0, so we'll have 0 times this bracket, which has to be 0. So we're looking for which one of these we can substitute both 4 in and -8 in, and get 0 in both cases. We've eliminated this one, and if we look over all the rest of them, this is the only one that has the roots of both of them. We can substitute 4 into this bracket and it will get us 0, and -8 into this bracket, which gets 0 too. Question 30. A pattern is made from two similar trapeziums. Show that the shaded area is 294 centimeters squared. If we're going to calculate the shaded area, we need the area of the large trapezium, and we have all the lengths we need for that. And we need the area of the small trapezium, and we're missing 2 of the lengths for that. First, let's figure out the scale factor that relates both these two trapeziums. Since they're similar, we'll take this small side here and divide by the small side on the similar trapezium, that's 4. So our scale factor is 2.5. This trapezium, the large one, is 2.5 times bigger lengthwise than the small one. So we can figure out the base here of this one by taking 18, the large side on the large trapezium, and dividing by the scale factor of 2.5, which gives us 7.2 centimeters, this length here, on the small trapezium. We can do the same thing for the height here, so 25 divided by 2.5, which equals 10 centimeters, the height of the small trapezium. Next, let's calculate area. The area of a trapezium is given by half this side, add this side, and then multiplied by the height. So let's call the large trapezium 1 and the small trapezium 2. So the area of 1, it's half of the long side here, 18, plus the short side, 10, multiplied by the height, 25. It gives us an area of 350 centimeters squared. Let's do the same for the second one. Area of 2 is a half times 4 plus 7.2, 10, which gives us an area of 56 centimeters squared. If we want the shaded area, we need to take this away from the large area. So area of the shaded area is 350 minus 56, which is 294 centimeters squared, as required.